everyone, my name is Hemu and in today's we are going to discuss SSL decryption concept in your Palo Alto Firewall. So in SSL decryption basically we are having a couple of topics, like first I will go through with the SSL handshake, how the SSL handshake process works. Then we will see, I will give you the SSL decryption overview or SSL encryption overview. Then we will look for the certificate management, like what is self-signed certificate or what is the like CA issue certificates, what is forward trust, what is forward untrust certificate, what are the impact we are having for decryption, outbound SSL decryption and inbound SSL decryption, most important topics. Then decryption profiles, SSL decryption notification page, hardware security modules, and once we will complete, we will basically also see some debugging part of it. And guys, here I will give you the advanced level overview of the SSL decryption, like SSL inbound inspection and SSL outbound decryption. In-depth overview means we will see all type of aspect of it, how the PAN-OS used to handle the SSL packet. Okay, so before going into that one, let me just basically create some context for that. So let's suppose I will first draw one diagram here. Let's suppose I have a host here. This is PC1. I have this PC1 here. Let me go like that. Actually, I have upgraded my whiteboard and this whiteboard is very, very sticky actually. I have this PC1 here. This PC1 have a connectivity with the firewall. This is my Palo Alto Firewall. This Palo Alto Firewall have a connectivity with the internet service provider. And I'm going with the very, very basic setup. And over the internet, we have couple of servers, like we have a facebook.com. Then we have a gmail.com. Apart from that, this interface is Ethernet 1x1. This interface is Ethernet 1x2. This interface part of inside zone. This interface is part of outside zone. And I do have one more interface called Ethernet 1x3. This is my DMZ interface. And behind this DMZ interface, I have one server here. Server 01. And that server 01 having the hosting his services on port number TCP 443. Means it is basically hosting all the services over the HTTPS. This is the basic setup now we are having. Okay. They have a connectivity somehow like this, and we have couple of internet user over the internet. This is one of the internet user. Okay, this is the internet user I'm having. Now, let's try to understand what used to happen. Guys, tell me one thing. So before coming into this diagram, let me just give you one more overview here. Let's suppose there is a one person. Okay, there is a one person. He is basically sitting in his car, and let's say this person wants to go from this place to this particular place. Till here he wants to go. So he has a road here. Now tell me one thing, and on this road there is a couple of peoples are also available. Like behind this, like we have a road, then in the side of that road there is a couple of peoples are there. Now just tell me one thing, let's suppose when this PC or when this person basically move from here till here, are these people able to see him or not? They can able to see him clearly, right? Because road is open. And let's suppose in this car, this is a some type of loading car. He has just loaded some type of luggage here, and that information also they will get. What is the information available into this car? That information they will get easily. Or you can think out like this is a truck, and he has loaded some articles on the truck. These people can easily able to see what is the things available into that truck, right? Now, so because now they are able to see everything, which means if he can basically cover the stuff, what he can do, if he can basically cover all the articles, in that case what these people able to see or not? They are not able to see in that case. Or let's suppose what they did, basically what they did, they have created a direct tunnel from here till here, and now this particular truck is moving inside this tunnel. Is anyone who is basically inside in a side of this particular tunnel, are these people able to see anything here this time? No, right? Which means they are basically now exchanging the thing in a secure way, because no one able to see. And if no one able to see, which means they are basically exchanging the information in a secure way, and this is known as encryption. When we will exchange the data in secure way is known as encryption. Let me just take another analogy. Let's suppose I have a person here. I have one person sitting into this PC1, and this PC have a connectivity over through this internet with the another computer here, PC2. Okay, now let's suppose this PC wants to communicate with this particular PC, means PC1 wants to communicate with PC2 over this particular internet. And let's suppose for when they are communicating using the HTTP protocol. And if they will use this HTTP protocol, and if there is a one person sitting over the internet, and what he is doing, he is watching everything. Maybe he is basically using any type of sniffing tool. Any type of sniffing tool he is using, like a Whiteshark, and he's basically capturing all the data. Because in internet, what is internet? Internet is a combination of multiple routers connected together, right? And this person is watching everything. So if they will exchange any data using this HTTP, this person able to see everything, right? But what he can do, if that person, they will start using this HTTPS. Now, in case of HTTPS, when this person basically capture the data, what he will get? In case of HTTP, he will get the encrypted data, right? And if this PC is this particular person or attacker or hacker, if he is getting the encrypted data, is this hacker able to get anything from this particular encrypted data? Yes, no? Guys, so are you able to basically get any information from this encrypted data? No, right? It is not possible. It cannot able to understand the data. Encryption means, let's suppose this PC is trying to send one message called hi toward this PC. What he will do when this data go into the wire, what will happen? He will basically encrypt that data, and instead of hi, maybe he's getting this type of data. Are this PC able to guess from if this data? He, because for hi we have encrypted with this. Encryption means we are changing the data. We are changing the data, right? Now basically this is how the encryption works. Encryption means we will change the clear text into the cipher text. And decryption means we will convert the cipher text into the clear text. And when we will do the encryption word, we have to basically use some type of method or some type of mechanism who can do the encryption. And we need some type of key. So this particular mechanism, by using this key, we can able to encrypt the data. And we also need a key and mechanism to basically decrypt the data. Okay, so just remember these things. And guys, these are the some cryptographic concept, and these concept I have covered on that particular video. Okay, now let me just come into the SSL decryption. Now guys, tell me one thing. Now here, what I am having Palo Alto Firewall. Let's suppose this PC is trying to communicate with facebook.com. And if you have observed, Facebook is hosted over TCP 443. When you will communicate with a website who is hosting its services over port 443, what used to happen between this PC and this particular website of this Facebook? They will create a secure tunnel, and that secure tunnel is known as a SSL tunnel, or I can say TLS tunnel. Means whatever data they will exchange, or whatever data this PC and this Facebook server exchange, that data is encrypted now. So now tell me one thing, is this firewall able to basically see anything on that data? Guys, is my Palo Alto firewall able to see that data in the default behavior? What is the content this PC and this particular server they are exchanging? He is not able to see. And if this firewall is not able to see, then tell me one thing. Let's suppose on this server, they are exchanging some type of malicious data through this particular tunnel. Is my firewall able to see this particular malicious data? Maybe they are exchanging some type of virus or some type of malware. Is this firewall able to get the detail of this virus or malware? Firewall is not able to get that data, or he will not able to identify the virus and malware, because data is in encryption, because data is encrypted. So now, but if you want a protection from these type of malware or viruses, what you need to do? You need to basically do some type of configuration into this firewall. So what he can do, whatever data is exchanged by this PC and this particular Facebook server, this firewall can able to decrypt it. And if this firewall able to decrypt that data, that time he can able to see. He can able to see the actual data, and after that he can able to apply the inspection on data. Means he can able to process the data at layer 7. Means he can able to do the layer 7 processing, or it will apply the inspection. It will apply the inspection for the content ID or content engine of your Palo Alto Firewall. Do the inspection against the malware, threats, viruses, vulnerabilities, all these kind of details. And what it will do, it will check if that data is a clean data. If it is not having any type of malware or virus, it will allow that data. And if it will found any type of virus or malware, what it will do, it will basically block that data right away. It will block that type of packets right away. So now I hope you understand the encryption, you understand the how we need SSL decryption and why we need to configure this as SSL decryption in the firewall, because without SSL decryption, you will not get the 100% results. Okay, you will not get the 100% result, guys. Just remember, this is the overview of your SSL decryption. And remember one thing, when the session is initiated by this particular PC1 or your LAN users or your DMZ users, and if they are sending that data towards the internet, and if you wants to configure the decryption for that type of session, in that case you have to configure the SSL outbound decryption or SSL proxy. SSL outbound decryption. Apart from that, if you will see, we do have a this particular server on your DMZ. This server is also hosting its services on TCP port number 443. And let's suppose now this internet user wants to communicate with this server. So what he did, this internet user, he has basically created a SSL tunnel with this particular server. Now tell me one thing. Now whatever data is exchanged by this particular server, DMZ server, and this internet user, are this firewall able to do anything? Because all that data they will exchange in clear in the encrypted, all data is encrypted, right? And if data is encrypted, my firewall not able to see anything. So what we have to do, if you want to configure, if you want to make some configuration on the firewall, so he can able to decrypt these type of packets as well. For that, you have to configure the SSL inbound inspection in your Palo Alto firewall. So we have a generally two type of SSL decryption. We have a outbound SSL decryption and we have a inbound SSL decryption, or this thing is also known as inbound SSL inspection. And this outbound SSL decryption is also known as SSL forward proxy. Okay. Now I hope you will get the basic idea of this particular SSL decryption. Now let me just tell you guys. Now what we will do, first we will try to understand the SSL handshake. What is SSL handshake? Because if you got the idea of SSL handshake, and after that only we can able to understand the rest of the things. So now let me just tell you the SSL handshake in detail. So first, if you will see this particular diagram, in this diagram, you can see we have a client and we have a server. So guys, always this SSL connection is initiated by the client machine, because just tell me one thing, when you are trying to communicate with the Facebook, you are the one who needs to start the connections, right? Tell me one thing, you will start the connection or Facebook will start the connection with your mobile phone where you are running the Facebook application, right? This client is start. So what used to do, this client will send one packet called client hello. So the first packet which is initiated by the client machine is the client hello. That client hello has some cryptographic information. And after that, this server, he will send the server hello. He will send the server certificate. And maybe this, as this server, what he will do, he will ask this particular client to present his certificate as well. And after that, this client, what he will do, generally this option is you needed when you have enabled the mutual authentication. In normal cases, like when you are communicating with Facebook, this option you will not see. And after that, client send one message called client key exchange. Send client certificate. If he has asked that thing, then client will send the certificate, but this is also optional thing. Then client send client finished, server send server finished, exchange message, and like that they will basically complete the SSL handshake. This is the very, very basic overview of the SSL handshake. Now, let me give you the advanced level overview, how the things used to happen. So for that, I need some space. Okay, now let's try to understand the SSL in detail. So let's suppose here I have a client machine. This is client machine. Here we have a firewall. And here we have a server. Let's say server I will connect directly. Let's suppose that server have IP address 151.7.1. It is running his service over TCP 443. And this server is a web server, let's suppose, for example. Okay, now what will happen? As I have mentioned, if this PC, let's say this PC IP address is 10.1.1.70. Now, if this client machine wants to communicate with this server, and this particular server hosting its service on port TCP port 443. So guys, in case of TCP, what is the first thing? What is the first thing they need to basically complete? What is the first packet initiated by this client machine toward that server? They will go through with the TCP 3-way handshake first. So the first packet is your client hello, or the first packet is your, sorry, not client hello. The first packet is your TCP SYN. TCP SYN. And after that, file will process this TCP SYN and he will forward this particular packet till the server. Now this server will give the reply and he will send the second packet, which is TCP SYN plus ACK. And after that, they will send the next packet, which is the third one, TCP acknowledgement. And guys, by exchanging these three packets, they will complete the TCP 3-way handshake process. They will complete the TCP three-way handshake, and now session TCP connection is in established state. And guys, once TCP three-way handshake will complete, what they will do, this particular client PC now will send the next message. That next message is known as a client hello. Means now your SSL handshake is started from here. Now your SSL handshake is started, and the first packet they will send is your client hello. Now in this first message, what is the information is available? What are the parameters they will exchange? So guys, before going into this one, for your SSL handshake, there is a one protocol called SSL Handshake Protocol. There is a one protocol called SSL Cipher Change Protocol. There is a one more protocol called SSL Alert Protocol, and there is a one more protocol called SSL Record Protocol. These are the four protocols who is responsible for your SSL handshake process. If there is any error in your SSL handshake, this SSL alert protocol will generate the error messages. To manage your cryptographic keys, we have a SSL cipher change protocol. Let's suppose your key timer is expired, or they needs to generate they needs to basically load the new keys. This particular SSL cipher change protocol will do the things. And who will start the SSL handshake? We have a SSL handshake protocol. And this SSL record protocol maintain the packets delivery between the application layer and your presentation layer. It will maintain all the records, compression, decompression, all these things done by the record protocol. And guys, according to the OSI model, all these four protocol works between application layer and your transport layer. SSL stands for secure socket layer. SSL is a standard security technology for establishing an encrypted link between a server and the client. Client always initiate the connection. Means who will initiate the SSL connection, which is a client. And there is a company called Netscale come with the SSL concept. So this is the organization who has basically developed this particular concept. And they launched the very first version of SSL, which is SSL 1.0, which is not released. And after that, they have launched SSL 2.0, 3.0, then SSL 3.1, which is also known as a TLS version, which is also known as a TLS. This is known as a TLS 1.0, 1.2, and TLS 1.3. And guys, in your SSL handshake, first TCP three-way handshake happens, and after that your SSL handshake will start. Just remember this part. This part you have to remember. Let me, I have to change the style here because I have to do the word wrapping somehow. Yeah. Now, as I have mentioned, in SSL handshake, we have a very first packet, or you can say like phase 0, but I don't, I like it is not divided on the phases, but just for the understanding purpose, I have written like that. Like they will exchange the very first packet, which is a client hello. In this client hello, what he will report, what is the SSL and TLS version? Means what he will report here, he will report the SSL and TLS version. He will also send one random number. This is the random number which is generated by Okay, so you are talking about this part, guys, are you able to see this part? This line, you guys able to understand or not? It is visible properly. Let me just change the style here. Current line. White is also not good. This is also not good. I was using this one, I think. This one is clear now, guys. Color is not visible. Now it is also not visible, right? I'm talking about this line only. It is visible, yes, no? Not clear. This is the background. Let me use then black. Okay. Now, so the very first packet, it has a SSL TLS version. It has a random number. It has a session ID. It has a cipher suite. It has a compression algorithm, and it has a extension fields. These are the packet which is available in your client hello message. Means what is the information available? SSL TLS version, random number, session ID. Random number, session ID, and generally the session ID value is 0 in the first packet. And after that has a cipher suite. What is the cipher suite? Means it has a combination of encryption algorithm and hashing algorithm. It is a combination of encryption algorithm and hashing algorithm. Like let's suppose I want to use 3 dash for the encryption purpose, and I want to use SHA-256 for the hashing purpose. So it has a all type of combination, and we will see that combination, guys, in some time. Compression algorithm and the extension fields. It has a compression algorithm. Then it has some extension fields. Now this is the information available into the very first packet, which is a client hello packet. Now this particular client, he will forward this packet over this server. Now before that, and guys, here you can see I have put one note. This SSL and TLS version is always decided by the client machine, just remember. This particular decision for SSL and TLS version is always happening on the basis of or done by the client, just remember. Now we have a session ID. What's that? It's a, generally in the client hello we have a, most of the time we have a new session ID, and by default this new session ID value is 0 from the client side, and server will give the new session ID always. Sometimes you will see the concept of resumed session ID. Let's suppose you are basically, you have just saved the session ID details, and you have saved the cookies and other thing. In that case, it will, they will also sometimes resume the session. So old session ID which provided by the server, so that time you will see that detail. New session ID, we have resumed option. When we resumed the session, certificate will not exchange. And guys, if we are resuming the connection, certificate exchange will not happen again, just remember. And sometimes you will see the null session ID where it don't have a resume session ID option. And guys, this session ID is always provided by the server to the client, just remember. And after that, the second message which is initiated by this particular server is the server hello. What is the second message which is server hello? And in the same message, what you will see? You will see here, you will also see the server certificate. And the fourth thing is server hello done. These are the three messages will come as a single message, guys. So the thing is, because here server will send some huge data. So this size of this particular packet is sometime you will see very big. In server hello, what you will see? You will see the selected SSL TLS version. You will see the server random number. Whatever the session ID previously we have 0 here, now you will see some session ID here. Here, and after that here you have a accepted, or I can say agreed cipher suit. And you have a compression algorithm and selected SSL TLS version, selected cipher suit, selected compression algorithm, random number from the server side, session ID. And after that, server present his certificate. We will see the server certificate. And server may ask like server key exchange, but this concept is not there now. This concept will be there in 2002 in US. Server can also ask the certificate from the client. This is also optional. You can see all these are the optional one. And after that, the last packet, which is server hello done. Now guys, what used to happen in this server certificate? What you have, this server certificate, because you know this particular server, it has a two things. It has a public key and it has a private key. It has two type of keys. Private key, this server never share with anyone because it's just a private information. It will never share with anyone. And we have a public key. Let's suppose public key value is 20 and private key value is 30. And guys, let me tell you one more thing. We have a private key and we have a public key. And guys, when we will drive these keys, when the server calculate or generate these keys, first private key will be generated, and after that, using this private key, we will generate the public key. So means public key just some part of your private key. Just remember, here I am taking these hypothetical numbers. So what used to happen when this server used to get the certificate? When this server used to get the certificate, that time this server will share his public key. So when here server is sending his certificate, so what used to happen generally, here I can say server will send the certificate chain. Here you will see the root certificate. Let me use the another highlighter here. What server will use here? Send root certificate, then intermediate root certificate, and after that here you will see the end user certificate. End user certificate means this is the actual certificate of that particular server. Now this end user certificate, what it is having the public key. It is having the public key. Now when these three messages receive this, when this message received by this particular PC, so what this PC will do, or this client will do, what it will do, it will basically generate the pre-master key. Generally it has a pre-master key. It generally it used to generate this pre-master key, and what it will do now, this pre-master key information, it will encrypt using the public key which he has received into the server certificate. And after that, what it will do, it will send one more message here. It will send one more message here. This message name is client key exchange. Plus, here it will also send one more message like change cipher spec and client finished. Now, guys, let's suppose we have a pre-master key value is 50. I am taking these are the hypothetical number. So what it will do, it will encrypt this particular key by using this public key, which is 20. And let's say he has get some encrypted data here. And now this is the data he will send here. So means I will put here, it will send this pre-master key value, which is 50 in encrypted form. And guys, let me tell you one more thing. Whenever you will do the encryption, let's suppose if you have encrypted anything using this public key, if you encrypted any information with this public key, you are only allowed to decrypt it with the help of this particular private key. Otherwise, you will not able to decrypt. And if you have decrypted anything with this private key, you are only able to encrypt it with the help of public key. Because they will use here asymmetric encryption algorithm, or they will use the asymmetric encryption algorithm method for the SSL handshake process. Now, guys, tell me one thing. Now, this particular encrypted key we have received here or not? We have received, because this particular pre-master key, this PC has encrypted with the help of public key. Now we have a private key here. So this particular server, he can able to decrypt it easily. And now just tell me one thing. This server, he will get the pre-master key. He will get the pre-master key 50 here. Now, because if you have observed here, he has sent the client client random number, and server will also send his server random number. So what they will do now, this particular this particular server, he will use this pre-master key and he will use the client random number plus the server random number, and what it will generate one more key which is known as a master key. That's how they have generated the master key, which is 60 hypothetically. Now guys, tell me one thing, this PC will also have the client random number and the server random number, so he can also generate the master secret. He has also generated the master key, which is 60. And by using this master key, they will generate the session key. This session key, let's suppose they have generated 100 here, and they have generated the session key 100 here. Once this process will complete, what will happen now? Now this particular server, what he will send one more message here. What he will send in this message, he will send server key exchange. Let me go a little bit up here. Client key exchange, client verified the server certificate, change cipher spec finished, change cipher spec finished. So guys, generally, let me tell you, here I was wrong. Here server just sends the one message called change cipher spec and finished. And the meaning of this particular the meaning of this change cipher spec is that they are just telling each other we have generated the session key, and now whatever data they will exchange, they will basically use this particular session key for the encryption and decryption purpose. And at by end of the day, you can see they are using the same session key for encryption and decryption purpose. Means here your application data will go, and this application data they will encrypt and decrypt using the same key. So the final thing after the SSL handshake will complete, because you know your SSL handshake will complete here. Now whatever data they will exchange, it is all encrypted, no one able to see anything. And that's how they used to basically complete the SSL handshake process, guys. This is how they will complete the SSL handshake process. Let me take one more neat and clean diagram, because this is the one. Now we will discuss few more details here. You know, this whiteboard is not basically responding properly. This is not good, but I just have this one only. Okay, so here also I have written the same process. Now let's basically verify the same thing with the help of Whiteshark Captures. I'll go here. So if you will see, these are the Whiteshark Captures. In this capture, if you will see, this is the client IP address 172.16.0.62, and this is the server IP address 172.16.1.187. Now you can see, when they have started the communication, when this client started the communication with this server over the destination, they are basically sending the very first packet, which is a TCP SYN packet. And in this TCP SYN packet, if I will basically go a little bit up, and if I will highlight this TCP SYN packet, you can able to see in TCP SYN request word, you will see the source port, you will see the destination port, you will have a sequence number which is 0. So in the first packet, we always have a sequence number. Generally, This is the sequence number. Sequence number is not 0, but we have a acknowledgement number which is 0. Okay. And apart from that, we have a flag here, and you can see they have just set the SYN flag. They will exchange the window size, right? And in optional field, they will exchange the maximum segment size, Windows scale factor, timestamp, selective ACK is permitted. So these are the details which they are exchanging in your SYN request. Then we have a SYN plus ACK. In SYN plus ACK also, you have a source port, destination port. Here you can see acknowledgement and SYN flag is set, which means it is just a SYN plus ACK message. We have some TCP optional field. We have a calculated Windows size, checksum value, and other things. And after that, we have a acknowledgement number. They will, you can see ACK flag is set here, which means we are looking into the correct packet. And now you can see till this point they have completed the TCP 3-way handshake. And once they will complete the TCP 3-way handshake, what they will do? They start the SSL handshake. In SSL handshake, the very first packet which is exchanged by these peoples is your client hello packet. In this client hello packet, if I will open this TLS transport layer security, which is TLS packet here, you can see they have defined the SSL TLS versions. They are using TLS version 1.0 here. This is the length of the packet. Handshake protocol. The packet name is client hello. They have a TLS version. So this is the actual version of your TLS which they are using. TLS version 1.2. This is the random number. I have mentioned this random number, right? Protocol version, then random number, and they are exchanging this random number, guys. These are the random bytes. Then we have a session ID. Length is 0 and session ID is also 0. And after that, they will exchange around 36 cipher shoots. Means they will exchange the encryption and hashing and authentication methods here. If I will open the cipher shoot, you can see this is the combination. In the first one, they want to use ECDHE, elliptical curve Diffie-Hellman algorithm, with AES 128 GCM as an encryption algorithm and SHA-256 as a hashing algorithm. So they are using somewhere like ECDHE, somewhere they are using RSA, right? So you will see all the combination of these particular algorithms, cipher shoots. And after that, they will exchange the compression method if there is any compression, and they have a extension fields. They have a extension fields like reserved field, then renegotiation info, server name, and this is most important. Here you will get the server name. This is the name of the server. If you are accessing Facebook, that time you will see the facebook.com here. Right now you can see server name is cs-webserver.lan. These are the details they will exchange in the first packet. And guys, whatever details I have written on my whiteboard, it is the same detail, right? Now, and after that, you can see we get the acknowledgement. And now you can see this message, the next message which having server hello, server certificate, and server hello done. And in TLS, you can see this information. Let me just open here. You will have a 3 packets inside the single packet. We have a TLS 1.2 record layer. We have a handshake protocol where we have a server hello, server certificate, and server hello done. Means this particular information just coming into the same packet. This one. And size of this packet is little bit high, 746 bytes. Now you can open the first package, which is server hello. In server hello, we have a SSL TLS version, the selected one. Then we have a random number from the server side. This is the server random number. We have a selected cipher suite. You can check the cipher suites here. We have just this cipher suite. Only the one on which they have agreed, and they have agreed on TLS RSA, where they are using AES 128 GCM as an encryption algorithm and SHA-256 as a hashing algorithm. And they are exchanging some extension fields. Compression method null, which means they are not using any compression here. This is some other detail. Okay, this is the first packet, which is server hello. Then we have a certificate detail. In this certificate, you can see they will exchange this entire certificate chain. Even though if I will basically open here ICICI Bank website, let me just show you what is the information they will exchange. If I'll go into this one, if I click on connection is secure, certificate is valid, detail, you can see I will get this entire detail. Here, this certificate is the root certificate. This certificate is the intermediate root certificate. And this is the end user certificate, means this is the actual certificate of ICICI.com, end user certificate. And they will basically exchange this particular entire certificate chain. And in this certificate, as I have mentioned, if I will basically click on this ICICIbank.com certificate, if I'll go here, you will get the certificate version, serial number, signature algorithm, issuer detail, who has issued this certificate. This certificate is issued by the end trust. Validity is there. Subject is there. This is the subject, and the certificate is issued for ICICIbank.com. This is the location, Thane, Maharashtra, India. Then this is the subject public key algorithm. This is the public key. Guys, this is the public key which I have used one number, but in actual this is the actual key. The subject public key. Then this is the some other information, subject key ID, authority ID, authority information access, CRL distribution, all these detail, key uses, and all these things. Server alternative name. This certificate is only valid for www.icicibank.com. And the most important part of this certificate, this is the signature of that certificate. This is the hashed value, and we have a fingerprints. SHA-1 fingerprint and SHA-256 fingerprint. This value is unique. This is the hashed form of that particular certificate data. Okay. Now, if you go here, go into the detail again. This same detail is available into this certificate. Same detail is also available into this certificate. But this certificate has a detail of interest root certificate authority. This certificate has a detail of interest certificate authority. Now, you can ask one question. How my end PC will sure this certificate is the correct one? This certificate is the correct one. So guys, tell me one thing. Let's suppose you are from India. You are from India, right? And let's suppose when you used to register for any type of policies, let's suppose when you wants to basically you are going into the bank and you want to open your account into the bank. What is the first ID they generally ask? If you have a valid Aadhaar card, they will accept this Aadhaar card, right? If you have PAN card, they will accept that PAN card. And who has basically issues this Aadhaar card and PAN card? Indian government. Right? Because you know, this is you, PC1. Let's suppose this is the bank person. How this bank person is basically trusting on this particular PC or this particular person, and how this particular person is basically trusting he is a correct bank person. What he will do, this PC, he will present his basically ID card in front of that person, and that person may also present his ID card, maybe the Aadhaar card. So what we are doing, there is a one common authority. There is a one common authority because this PC has a full trust on Indian government, and this also has a full trust on Indian government. And whatever issues, whatever the ID card is issued by the Indian government, both people are trusting on each other on that behalf. So your root certificate thing is also works in the similar way. What? We have a root certificate. We have a root CA. So guys across globe, we have around 7 to 8 root CAs. And after that, these root CA, you can think like a government. These root CA, you can think like a government. Now we have a one person here, we have a one person here. Because you know, if anything, if any ID is issued by this root CA to this PC, and any ID if issued by this root CA to this PC too, and if this PC, when he will, if he is presenting that ID means that certificate, let's suppose cert 2 and he is a cert 1, and if he is presenting his cert 2 to this PC1, what this PC1 see, he will check, oh, this certificate is issued by this root C. Let's suppose I will take a very popular root C authority, which is DigiCerts. This is the one of the root certificate authority. So let's suppose this certificate 2 is issued by the DigiCerts. Because this PC know he's a trusted authority, and if anything which is issued by that authority, I will trust blindly. So that's how he will basically trust on it. In the similar way, when this PC1, he will present his certificate to PC2. Let's suppose this certificate is basically issued by the interest. There is a one more certificate authority, or maybe it's issued by the GoDaddy. Because this PC has a full trust on GoDaddy and interest. And if he is presenting that ID, this PC2 will also basically accept that particular ID. That's how they do they will basically maintain the trust. That's how the trust is maintained in your internet world. And now if you will see here, because you know we have this certificate. Let's suppose if somebody has done any type of changes. If anyone has done any type of changes, what will happen? Because you know this value, this fingerprints value will change. If anyone has modified any information, fingerprints value will change. And guys, this certificate will also having this fingerprints. And if anyone has modified any information into this certificate, what you can do, because in our system we have a one certificate. If I will type here manage computer certificates, click on OK. You can see the same certificate I'm also having here. If I'll go on a trusted root certificate authority, I will open this. And let me just open that certificate for interest. We have this certificate interest one. Just open this certificate path detail. Look for thumbprint. Interest, what is the interest.net certificate authority, and this is the interest root certificate authority Z2. So I think this is not the correct one. Do I have anything else here? I just have a one for interest. Let me just see. I don't have here as well. I just have a interest.net only here. Trust publisher. This is not the one. Personal. Let me just know. I don't have any personal one as well. Generally what they happen, this particular value will match. This value will match basically on this certificate. They will check this particular thumbprints. So let me just try to open the sdfcbank.com. SDFC Bank. Let me just look for the any website whose certificate is signed by the DigiCerts. DigiCerts High Assurance EB. Fingerprints. Just look for this DigiCerts one now. This is the one. Open this one. Go into the detail. Look for this thumbprint. This thumbprint value is different. Certificate signature, fingerprint. Signature algorithm is SHA-1 with RSA algorithm. Generally this value is similar. Basically I am not able to get the detail. Maybe I was looking something else. Signature value, certificate authority ID, component. Let me just look all the details. Signature algorithm is SHA-1 with RSA. This is the serial number of that certificate. These are assured ID root CA. High assurance EB. This is the one. Let me just open this one. Basically go into this certificate path detail. Look for the thumbprint. Go here. SHA-1 thumbprint. See, this value is matching with this value, guys, right? Because previously we are looking the wrong certificate. So what? Because you know this certificate is already there in your PC, and they will always match this thumbprint. If this thumbprint and this value will match, what will happen? They will basically validate, oh, this is the correct certificate. And if we will trust on this certificate, which means we need to now trust on this one, and we need to trust on this one. That's how they will maintain the trust. Means if I will trust, I have a trust on the root certificate, then I will trust on the entire certificate chain. Okay, so that's how they will maintain this thing, and they will use this particular fingerprints value. to do the things. Okay, because you can see this value is clearly same, ending with DC25, DC25, you can see. So this is the information which I wanted to tell you. So I was in this particular server hello, right? Here we are looking for, right? So guys, here also you can see we have a certificate. This is the entire certificate detail only, but this detail you are able to see in the Whiteshark form. We have a web server detail, but maybe they just have a here single certificate, so that's why you are not able to see the root certificate. Okay, then we have a server hello, then just a normal packet, and after that I have told you client will send the client key exchange message, right? In client key exchange message, you can see here, you will see the client key exchange message, chain cipher spec, and finished. In client key exchange, if you will go here, you will see this particular encrypted pre-master key in this form. This is the pre-master secret in the encrypted form, and this is the data they will exchange. And after that, we have a here record protocol. Chain cipher spec means now what they can do. Now we can go and just change the cipher spec, and we can start encrypting the data using the aggregate or using the agreed parameters. Here you will see the chain cipher spec from the client side, and after that, whatever the application data they will exchange, you can see everything is encrypted. That's how the SSL handshake used to complete. Even though if I will go here into this server certificate here, let me just open the certificate. What the information we can able to see here. Here also we don't have a much detail, only the single certificate, but they will exchange the entire chain, and that chain I will show you, don't worry. Okay, so that's how guys they will basically do the SSL handshake, or that's how the SSL handshake will be happening between the client machine and the server machine.